Okay, this is how I like to think about changes in code and trying to prevent bugs from releasing. And if we think about changes in code, we've got the more changes we make, the more defects we insert. And so this relationship is described in this diagram with an arrow between the two, where an arrow implies that the more of the first thing at the beginning of the arrow, the more of the second thing at the end of the arrow. So as this grows, as code changes grow, so do defect inserts grow to some proportion or ratio. Now, because we don't want these defects to release, we want to find them or prevent them somehow, right? And one of the activities that we do to find them so that we can fix them before they go any further than the developer's desk or wherever we found them is to test them. So we take that change, we test it, and in our testing, what we're trying to do is introduce the conditions that hit the defect, cause it to manifest as a bug or a failure or an error or whatever. And then we want to detect the defect, know that we saw it, recognize. And once we've detected the defect, then we're able to do something with it. We're able to fix it, decide if we maybe just want to put documentation around it, something, but we got to get control over this defect. And to do that, we have to know it's there. So that's what the testing for is, to know it's there. The challenge that we face is that there are things which make the testing harder to do, get in our way of the testing. And there's a lot of things that I'm not going to talk about in this model. I'm talking about these three things that affect a certain dynamic in the model that we want to talk about. And those are difficulty anticipating the test condition, imagining them, knowing that they're there, knowing that they're relevant. That is hard to do based on different aspects of the system. Okay. Difficulty in controlling the test condition. So you may know what you want to cover, you may know the problems, but the environment, the application, the infrastructure, the test rig, the ability to control the behavior of the app or the data state or query the application to know what it's doing may be very difficult, and that difficulty impedes the testing as well. Likewise, anticipating the oracle. An oracle is something that tells us if what we're observing might be a problem, right? Some oracles are very easy. It might be, if I click add on an item, then that item should show on the next page or should show in the database as in my shopping cart, and I can query the database. It might be a very easy one to anticipate, where not seeing that would mean there's a problem, or it might be very, very difficult to anticipate. We might have data that's highly complex, and the relationships which could indicate bad might be something you don't know to anticipate. Okay. And so these three difficulties get in our way by reducing the probability of certain things in the model. And that's what the arrow with the dot on it indicates, is that the thing at the beginning of the arrow going up, getting bigger, drives down the thing at the end of the arrow, the probability of it happening, the size of it, the impact of it, whatever. And so difficulty to anticipate the test condition or to control the test condition impede our ability to create the test condition we need to make the defect manifest as a bug or problem or issue. Difficulty anticipating the oracle impedes our ability to detect the defect. Do we see it happen? Do we understand it? Okay, so that's what making that bigger does. So what do we do with these difficulties? How do we try to manage them? Because they get in the way of our testing and get in our way of knowing the defects are there so that we can fix the bugs. Well, let's talk about the first thing I want to talk about is trying to keep the defect from being there in the first place, like not even about detecting it, but preventing it from happening. And I'm going to use a hand-wavy term. Just careful coding is what I'm calling here, mostly just to keep this presentation compact. But there's a lot of techniques that you can use when you're coding to make it less likely you have a defect to begin with. Everything from the way you do your requirements collection to the requirements descriptions, design, communication, and sharing and review within a team, how you structure the code, the type of architecture you use, loose coupling, whether you've got strong designs that support dependency injection, and if you have really explicit contracts. There's what kinds of tools you're using for static inspection to help you identify patterns as you're writing code. What kinds of libraries are you using that force patterns of development which are less likely to have certain kind of bugs? There's a whole set of things that we can do which reduce the defect insertion rate as the code changes go up. Okay, they're important, they're powerful, they're effective, and they generally work very, very well. They have a limitation. And the limitation relates to the whole problem we're talking about with the hexagons. So you can't apply careful coding practices to a problem that was not anticipated by somebody, right? I use linters and static inspection tools as an example. A lot of those are based on coded pattern recognition, where you can recognize something like, here is a variable that was used before its value was initialized. And so the linter or whatever in IDE tools might say, you're trying to use this variable, you never initialized it, its initial value may be throwing you way off, and you may be like incrementing from something other than 0 or whatever. Depends on the language, depends on the compiler. But that kind of thing is a pattern that's anticipated. It's known, it's been seen before, and so people have written tools to recognize the pattern. Right? But you can only do this if you've already thought of it, or someone's already thought of it. So this means that as much careful coding as you can apply, it doesn't get you past the anticipation problem. Right? There's always this possibility you didn't think of a thing, or someone didn't think of a thing, or a way to avoid a thing through coding practices. So stuff is possibly going to get past you anyway. How do we deal with that? Well, there's another way that we can deal with it, and that is to simplify the code for testability. And again, it's like careful coding. It's a variety of techniques, not all of which I've listed here, but I've listed some to kind of give a hint at the kinds of things we can do. Loose coupling makes it easier to do the testing. More explicit contracts make the oracles more obvious, as well as make the test conditions more visible and easier to anticipate, right? Modular design isolates purpose in a way where you can say the conditions are simple on this component. There's a whole set of things that we do that make it easier to test. Now, a lot of times when people say you cannot test quality into a product, you have to prevent bugs, you have to shift left early and do your testing as you code. And they refer to this simplified code for testability as preventing bugs from occurring. I don't see it that way because I have a very specific definition of what I mean by prevent bugs. I believe prevent bugs means the defect was never inserted. So if we look on our model, right, we go from code change to defect inserted, that is where prevention of bugs actually happens, is as you're coding. What we're talking about here is making us more effective in the anticipatory testing, right? By simplifying the effort to do it and making some of the information more explicit, which reduces the difficulty anticipation. That is detecting a bug after it's already been inserted. So its creation wasn't prevented. What we are preventing is propagation of the bug from the local build into the repository or deployed into production or to other engineers. So it's not preventing bugs, it's preventing propagation of bugs. I like to keep that distinction because it makes a lot of other conversations more precise, easier to talk about. But at the same time, it's very popular to conflate these two together as preventing bugs. And in certain conversations, that kind of casual conflation isn't really that damaging. It's when we try to get very precise about exactly what we're going to do that I find the separations more useful. Regardless, this technique is very close to the developer. Usually we're talking about unit tests, which can happen as the code's being written, before if you're practicing TDD in a formal sense, but quickly and efficiently and in ways that's easy to run for the developer without creating a very large, complicated testing condition. It's a highly effective way to test code, highly effective way to write code and design it. And it tends to stabilize code. Just forcing it into these patterns tends to make patterns of code that are less buggy anyway. So it's popular, it's a good practice, it's a good thing to do to make this investment. It has a limitation. It's the same limitation that we have with careful coding. We can only exploit improved testability for problems we anticipate, right? We can only say, oh, if I need to be able to control the following value coming back from the dependent service, therefore I need to create the connection to it in a way where dependency injection is easy and I can write a mock to write tests for the following conditions. What if the service threw an exception? What if it threw certain kinds of exceptions? What if it returned different data than it might be expecting? And how can I force that so I know if my business logic deals with it? We're still talking about things that we have to be able to imagine to do. Okay, and so this, as effective as this is, and as much as it curbs the problem in toward the advantage of being close to the developer and shifted left, we still have this fundamental dilemma, which is if we didn't anticipate something, we can't use this approach to our advantage. Right? Anything that gets past our anticipation is still going to get out as a defect. Okay. So what can we do? How do we deal with this anticipation problem? So far, we haven't identified anything that really conquers it, that really overcomes it. What do we do? Well, the next set of techniques are about broadening our test conditions and broadening with a certain flavor of test conditions. So far, I've been talking about explicitly anticipating exact test conditions, like what if the input value is null, or what if the following field is missing, or what if this combination and this combination, because it's like our truth table says we should have these combinations of things. So therefore, this one, this one, this one, this one, and this one, and we make a list and we go through all those. Very explicit test condition where we know exactly which ones we're looking, and we know exactly what we expect as results, right? But there's other ways of creating test conditions where we don't have an exact understanding of what we want. And this is about broadening the test conditions, making the problem space bigger. And this is like the first thing we talk about on the list over there, higher test levels, where test levels are, from lowest abstraction to highest abstraction, unit test, component test, integration, end-to-end system, in production. That's the stack I usually like to talk about. And the distinctions between those are not so much important as much as you understand there's a rising abstraction level and rising complexity level and rising volume of what happens in the application whenever action is taken through the interfaces that are available at the top of those levels. So in comparison, if we take a unit test, right, the conditions that you're dealing with in unit tests are very explicit, very exact, and the return values are very exact. Thus, the oracles you can compare against tend to be very explicit and exact. So that's very far left, that low test level down at the unit test, far left where your careful coding and your simplify for testability is highly optimized, right? Most of that kind of work is expressed in a unit test. But as stated, we have to anticipate that. Higher level tests, let's go really, really high. Let's go to a system test or even in production, right? What's happening there is we're pulling in a bunch of behavior where just taking a single action, just hitting a page on a site or adding an item to a list or dragging something from one spot on a page to another spot on the page is hitting much more code than we would hit if we'd done things in unit test. It may be hitting thousands of code paths and combinations and looking at data that is ephemeral or coming in with race conditions and things like that. It's pulling in combinations of behavior we probably are not anticipating. It's making it much richer and much larger. It's broadening the test conditions. executing more code. It's a way of creating coverage that is much deeper, much richer, more likely to hit a defect we didn't think about being there. Okay, and it goes through with the list of the other kinds of test conditions, randomizing behavior, making things richer and more complex, looking at longer sequences of actions, thinking of things not from functionality, but from things a user wants to accomplish, and then saying, what do I use to do that? All of those have this effect of enriching the coverage and enriching the test conditions that you're going to exercise. Okay, and that gets us past, to some degree, the things we don't anticipate, right? It's not a guessing game. It's not random. It's not throwing your hands in the air. We can use very targeted and focused techniques still doing this, right? And say, I'm going to focus towards the following scenarios or towards the following priorities and such. But we are trying to get past the what if I didn't think of it problem in this technique. And what that does, as we see in the relationship diagram here, is it strengthens the create defect test condition effect that we're trying to have. But it comes with a cost, right? And that cost, there's a lot of costs that come with it, but the two I'm going to focus on are overwhelming results and false positives. So if you create more test conditions, you create more to look at and think about while you're doing that testing. Right, you've got a much more rich set of behaviors, visuals on the screen, data created by the system, data processed in the system, things going on in logs, events triggering off to other components that you might want to observe. That's a lot of stuff to look at and think about, and you can overwhelm yourself with that information. The other thing that happens as you broaden your test conditions is because you're creating more things to think about and ponder for failure, you create more possibilities of false positives. The case where something looks like a failure that might not be. And there's a tax to that, because every time you look at one of those, you have to spend some time deciding, is this really a failure or is it not? Right? And that exploration may be beneficial to your understanding of the system, okay, but it is a cost of looking for defects. And the more you're looking, the more you're broadening things past your anticipation, the more likely it is you'll come across something that you believe is a failure that is not. Okay. And this applies whether you're using automated tools to run checks for you, to do this kind of testing, or if it's just humans interacting with the system. Right? It doesn't matter. Both approaches have this possibility of false positive. And overwhelming results and false positives create a condition where the analysis is more difficult. The analysis is more expensive. Okay, and since it is, that impedes our ability to detect the defect. Okay, because we're looking at the output of the test conditions and trying to see if we understand them. There's another thing that we can do to expand our ability to find more defects, and that is to broaden our test oracles. So usually when we're shifted way left and we're trying to simplify the testing in a unit test, the most common recommended practice in unit tests is to check for one thing, right? You go in and you create some condition and you have some result. Assert on exactly whether or not that result matches what your oracle prescribes, right? Is the way that we usually write unit tests, one thing at a time. And that's to make sure you always get the coverage. If that unit test failed, it doesn't block further coverage. It's to make the output of the unit test more trackable, more specific, easier to understand, less likely to have other kinds of problems, right? Which is really great for getting high precision results that you can trust are what they say they are. It's much more likely to match that way when you use that practice. But it's dreadful at finding a lot of failures, because you're looking too narrowly at what could be a problem. So the approach is to broaden the set of things that might classify as a problem. And in that broadening, we tend to use things where whether or not something is a failure is a little fuzzier, a little uncertain. Sometimes we just add more oracles. We might have a very, very precise oracle that if you ever see this, it's bad, okay, but we just pile them on. So there is that technique. But then there's others where it's like, well, if you see this condition, it might be a problem, but only if the following other things are true, and only if what you wanted was this and not that. Sometimes there's time-bound cases where you say, well, the following things shouldn't ever persist longer than a couple of minutes, depending on what the users are doing, and things like that. Had that once with a multi-authoring service, where there were instances where users would drop out of the multi-authoring case into a local cache of operations and be out of sync, to deal with network latency kind of issues or network outages that were very temporal and fast, and then eventually connect back and sync back up again. So to be out of state on the collaboration and multi-authoring was a normal behavior, but not if it lasted longer than it should, right? That's a fuzzy oracle. We might have statistical patterns where something is okay being high unless it's a rapid spike from a prior state, or okay being high for a while but should drop down after a certain point. Things like that, statistical patterns, or larger wrong patterns. Subjectivity, like this looks wrong to me, it feels wrong to me because when I'm using it, it's confusing or something like that. There's a variety of things where the oracle is not exact. There's a little bit of I know it when I see it things where we don't know, but we're bringing our tacit sense of what may or may not be correct into looking at things, right? And that likewise increases our ability to detect a defect because we're looking at it with more comparisons against a variety of things. It has the same cost impact as broadening the test conditions. We're much, much more likely to hit false positives, where the oracle that we're using says, oh, no problem, if we take it strictly. But in judgment, we say, no, actually, that's fine in this case for reasons. Right? Furthermore, the more that you're comparing what your output against some expectation, the more results you have to look at. This looks bad, this looks bad, looks bad, and you've got to go through and evaluate them and decide. So it is impeding on that by making the analysis more difficult. So with both of these techniques on this impedance, the question is like, what you're getting from the expansion either returning enough volume in increased defects observed to pay off, or is it possible that by expanding to maybe more complex, more difficult conditions that people had a hard time anticipating, you find really golden bugs, things that if they had happened would have been very bad and very expensive to try to isolate and diagnose, right, in production. And so maybe just the expansion to find the really highly valuable defects justifies the impedance cost of the extra work. Okay, but that impedance cost is there. And so we've always got this contemplation of the value of that expansion and relative to the cost of having done so. Okay, and there's other negatives to it. This type of testing tends to be more expensive, but it's not always more expensive. Sometimes it's cheaper, which is why I didn't put cost on there. Plus, I was trying to keep the drawing simpler. So just these 4 components. And the balance that we get in the model with keeping the other things out, I think works out well. But this is the basic model that I want to talk about because it describes a dynamic of talking about what are we going to do relative to defect discovery and prevention. Okay, and let's just break it up into 2 halves, a left side and a right side, and then 1, 2, 3, 4 mechanisms, techniques, categories of ways of dealing with the defects, right? Where 1 is the careful coding, just don't write the defect. 2 is make it easier to test it in the moment where it's close to the developer, shifted left. And both of these share the anticipated situation where they're highly affected by your ability to anticipate, right? They've got that dilemma that no matter how well you do at this, you've always got the what didn't I think of constraining its effectiveness. Okay. Very close to the developer, very fast. Meanwhile, I'm covering up the word unanticipated with my little video of me talking, but the word unanticipated is down there at the bottom right. 3 and 4 are about covering for what's unanticipated by broadening either the test conditions we apply or the oracles that we use to recognize a problem, so that we augment our difficulty anticipating problem with techniques that widen the test conditions or widen the comparisons, right? And make up for the I didn't think of it thing. This tends to be right shifted, although we can do this very close to the developer. Like a developer could, in writing a unit test, inject stochastic data into what it's doing, or it could write low-level tests at the unit that randomly mix operations together in different sequences to see what comes out of it. So you can shift this left, these broadening the techniques things to the left, but they'll still have the same sort of costs associated with it, right? They're fuzzier results. The information takes longer to process, more false positives, but you can do it shifted left. So that's why I'm calling it kind of right. But it splits the techniques down the middle, right? Where we've got, well, over here is, this very shifted left, over here, with very tight, highly anticipatory stuff, and over here is more expensive, longer to do. Is the further right you go, the more this effect starts to come into play, right? But it covers for what you don't anticipate, and that's these two sides. And the reason I like thinking of it split this way is it helps in not just, well, there's two places. One is in the public dialogue about testing approach and development approach. But the other is just in thinking about what you're doing in a team or on a project or with code or in development or in testing. Okay, so the public discussion has tended towards people who will make statements or positions that pick one of these circles or one side of the line, right? So there's a very popular narrative that says we should get rid of all high-level testing, all end-to-end testing, all dedicated test roles, and move all testing to developers to prevent the defects before they happen. And usually in that conversation, they likewise conflate 1 and 2 in this diagram together, right? We're talking about coding techniques which reduce the likelihood of bugs, and then simplifications on the code that make the unit testing, contract testing, and local dev testing more effective. That's usually what they're talking about, when you look at that. And that is a very good recommendation to increase the investment in those activities. It's almost always the case that you should be doing more of that. It's very rare that a team is starved for that, right, if they're having problems. So I support the recommendation to do that, to shift a lot of energy towards 1 and 2. But the rejection of the other testing techniques is ignoring how powerfully impacting the difficulty to anticipate both oracles and test condition is on the ability to detect what is the defects in your application. And if you think about it, teams that are shifted all the way left are still having incidents in production. They still have the 3 a.m. thing where someone has to DevOps-wise respond and figure out, oh no, what did I do? MTTR is a real measurement on DORA metrics because of this, right? It's like, how quickly are you able to respond? And fast delivery of code with short lead times is an important part of MTTR because dev teams are trying to respond to defects they released, right? Well, there's a degree that you can afford that, right? Because defects are going to come out and you want to be fast. But there's also a degree to where your business really can't afford that. So if a business is saying we're getting more of these than we wanted, more than we can afford, then what they have is defects released in spite of the attempt to anticipate and deal with it beforehand. Right? So by definition, everything that you've got out there skipped your ability to anticipate. It got past it. Right? So we know just by the fact that we have incidences and problems and issues and bugs and unhappy customers rooting from defects in the code, that our ability to anticipate is insufficient to keep up with that volume. We know that. So we can't entertain any notion that we can close the gap all the way to 100% on 1 and 2, right? Maybe 2 satisfied with our level of it, but I have a feeling that a lot of stakeholders, a lot of business owners have escapes and incidences and bugs in their experience that they're grumbling about and upset about. And most certainly customers and end users have experienced harms that they're not satisfied with. So I really don't find the argument that a full shift left of anticipating every problem and getting ahead of it is the sufficient answer. I believe it has to be complemented. And what it should be complemented with is the practices that get us past the anticipation dilemma. They frequently happen later, they're frequently more expensive, and we have to figure out ways to manage that, and techniques where we can still do that kind of exploration without impeding our ability to release when we need to release. But if we don't complement what we're doing with some degree of this kind of behavior, then things are always going to get past us that we don't want to. We can flip it the other way. We can say that because we have such trouble anticipating, we're going to do everything in these large, I don't know what I'm expecting, therefore I'm going to make it big, testing approaches. That tends to, I believe, amplify the overwhelming results problem, amplify the cost of execution problem, which I don't have reflected here, but this type of testing tends to take longer, tends to be more expensive. That tends to hide or sometimes even encourage bad coding practices that instead of anticipating problems and trying to prevent putting them in or trying to prevent covering them while you're close to the developer, throw them toward the larger testing thing, letting bad architecture, tight coupling, and all sorts of things persist in the design, which snowballs the problems that get out. You overwhelm your ability to actually look because you're not doing so efficiently, and you release a lot of problems. So throwing everything to the right is a bad idea most of the time as well. Okay. What I believe is also bad is to take any distribution of these approaches and say it applies across an entire product or across an entire industry, as some people want to sell you, or applies against a given milestone or everything. I actually believe that our decisions about how to engineer something, whether it's the coding or the testing or the decisions about how to prioritize and triage, change on even a per change basis. Like you could say, well, there's a whole product and we'll do it this way, but then go down to the sub features and then go down to the scenarios, then go down to the user stories and the coding changes. As we go down and down and down, I believe that every single time we make one of those shifts, we find that the context and the conditions change enough to motivate a different distribution of how we're looking at each of these kinds of ways of trying to prevent defects from propagating or continuing or being created. Like we detect them and prevent them from propagating and such as that. We may find that for a given change, we really can be almost entirely, if not entirely, shifted left and just rely on what you can do really fast with the developer. Other changes may pull in so much subjectivity or so much integration of a complex system with the change that we find we need to do some degree of broader test conditions to exercise conditions that we didn't anticipate when we were putting the code together. So the context tends to rule in those cases, and that's the way I like to think about it. So this is the model I like to use. I've always intuitively kind of used this in my head to think about it. I diagrammed it this way because I think broken out in this way, it makes it easier to have these larger conversations about, in general, doing testing, but even specifically as you're working on a project and you say, what do we need to do here? Why do we need to do this? I'll give an example. One time working with a product team, was dealing with code that was trying to just change a backend service that another service and application was consuming. And the difficulty that they had was that the data state in the backend service was complex. It wasn't controlled through a contract, really. There was just another dependency that was just shoving data in with direct SQL writes. And who knew what the data was going to be or what the relationship really was going to be like realistically, right? The other thing is that the relationship of the consuming application to the service was not well understood. So the developer wasn't comfortable with the changes they were making in their application, in their back-end service, and whether or not that would break the application consuming it, based both on not really understanding the application's behaviors through the contract or understanding the data state that they were presenting that the client application was eventually going to use. This made the developer nervous about 1 and 2 in the on the side, the shifted left approach. The developer didn't feel that they had the capability with what they had at the moment to do the type of testing, to anticipate the type of test conditions they could do in unit or in contract, right? They didn't understand the consumer well enough, didn't understand the data well enough. They most certainly didn't feel like they understood what could be right or wrong in the data well enough to have a reasonable oracle, right? So in that analysis of what do I need to do, what they decided they needed to do was to cover in a much larger test condition, which was going high level with all the services and everything deployed at once, talking to each other, and indeed even a deploy into production and have a person look at production just after deployment where all the data was actually real and not simulated to see what kind of problems come up, which was a very expensive way of trying to solve the problem. Put production in threat that while we're looking, it may not be working. And so, they were like, can we do this after business hours where it's, those kinds of things. This model, thinking of it, this model, we can start to realize what was motivating the developer to want to look at it that way. And, the developer's trying to be conscientious, but what they're coming from is the difficulties expressed in the middle here, anticipating the oracle, anticipating the test conditions, and controlling the test conditions, because what they didn't have also was a way of creating that end-to-end system locally. They didn't have a way of creating the data that was realistic locally, right? Because of that impedance on their ability to control the test condition, they couldn't move the problem closer to themselves, right? And so they were seeking other places to do that testing. Where in the more long-term case, you might say, well, what do we need to do? Maybe we need to do things with the design to make the system more careful and less brittle for that. So over on the careful coding side, and maybe we need to introduce more into the design that makes the testability easier to isolate, easier to anticipate, so that you're not plagued with this really difficult testing condition that this developer had. That's an example of applying this kind of thinking to a very real situation, an actual situation that came up. So that's the model. This is the way I like to think about that problem. I hope it's helpful for other people. Thank you.